Okay guys, so last time we were talking about our sum and difference identities. We only got through 4 examples and my video was 20 minutes long. It actually took several hours to actually upload the video and get it to you guys. So I'm going to actually probably only get through a couple examples, but I'm going to keep the video shorter and try to get you the videos more often, just so they don't take so long to upload. So let's just jump right in. So we're going to be on this one, example 3. Find the exact value of sine A plus B given this stuff right here. Well, sine A plus B, we're going to be using number 1. Sine A plus B equals sine A cosine B plus cosine A sine B. So let's just copy that down under here. So we need to know that sine A plus B equals sine A cosine B plus cosine A sine B. All right, excuse me. Now, given sine A equals 4/5. Now, this is that, remember, sine is y over r. And cosine is x over r. It's meant to be an equal sign, by the way. This tells us quadrant 1. Remember, all our trig functions are positive in quadrant 1. So, 4 over 5. If y is 4, r is 5, x has to be what? Remember, we can find x. R is the square root of x squared plus y squared. But this is actually one of those perfect triples that we talk about, 3, 4, 5. So cosine A has to be 3/5. Now, we have one of our pieces now. Because we have sine A, now we have cosine A. Now we have cosine B already from right here. We need sine B. That's the only other piece we need, which we can get from this piece of information they give us right here. In between pi over 2 and pi, that tells us that it's in quadrant 2. Cosine is negative in quadrant 2, but sine is positive. If cosine is x over r, sine is y over r. Well, 12 over 13, that's also one of our special triples. You can use this special formula to get it again. But 5, 12, 13 is one of our special triples. So sine has to be 5 over 13. So we have our sine B has to be 5 over 13. So now that we have all of our pieces of information, let me just erase everything. We've got cosine B, we've got sine A. Cosine A is 3 over 5. And sine B is 5 over 13. Remember, we're using sine A, cosine B, plus cosine A sine B. Oops. So now we have to do is just plug all of this in. So sine A is 4/5 times cosine B, which is negative 12/13, plus cosine A, which is 3/5, times sine B, which is 5/13. So, as long as my math is correct, which please check at home, that would be negative 48/65 plus 15/65, which would give us negative 33/65 as our answer. So now let's do it again. So, since it's cosine A plus B, going back up to our formulas here, cosine A plus B, we're going to be using number 3. I'm going to go a little bit faster. Feel free to pause me. Cosine A plus B is cosine A, cosine B, minus sine A, sine B. So, sine A is 12/13. We're in quadrant 1. So that means cosine A has to be positive. So that means cosine A, 5/12/13 has to be 5/13. Cosine B, this means it's in quadrant 2. Cosine B is negative 3/5. Sine B in quadrant 2 has to be positive because sine is positive in quadrant 2. So it has to be 4/5 because 3, 4, 5. So now we're going to plug right in to our formula because I have my 4 pieces. I need 4 pieces: cosine A, cosine B, sine A, and sine B. So cosine A is 5/13 times cosine B, which is negative 3/5. Oops, 5/13. That didn't. Excuse me. Minus sine A, which is 12/13, times sine B, which is 4/5. So this gives me negative 15/65 minus 48/65, which is negative 63/65. So just something to remember. When they're giving you actually sine A. Okay, up here, the number that they were giving you, the number was being plugged into the trig function, okay? Down here, oh my goodness. Okay. They're actually giving you sine A equals 12/13. So the sine of A is equal to 12/13. So you're going to plug that whole value in for whatever you have in your formula, all right? So I'm actually going to stop there just so this doesn't take forever to upload. and then hopefully I'll get another one out to you here in the next, maybe even later today or early tomorrow.